Hello, hello. Yes, sir. Thank you. So, in last session, I gave some brief example of application of Fourier series, right? And then I just introduced some Fourier integral and application. So, in this session, we will do this Fourier integral and Fourier transform example. Okay. Any question from your side? Okay. So, in Fourier series, the application involving that the expansion of the function fx of p period to sorry
सर एक क्वेश्चन बता दीजिए
हाँ बोलिए
फोरियर ट्रांसफॉर्म का द फोरियर ट्रांसफॉर्म
the Fourier transform of
ऑफ
triangle function
when fx is equal to
when fx equal to
1 minus mod x
1 minus mod x
mod x is less than 1
when x less than 1.
yeah
Okay.
and next 0 when mod x is greater than 0 greater than
Greater than 1. Okay.
w is equal to sine omega over
Sorry, CW sin omega over omega. What is CW? But there should be some definition. What is CW?
I don't know question ही यही है yeah
This is sin. Eh?
sine CW
Oh,
C omega sine C omega. Given that sine C omega is equal to sine omega over
what is this? Like which one reference to 12? Number. Okay, this omega is in frequency form, right? And because Fourier transform gives the time function when you are convert the time function to domain to frequency domain, right? So I could not understand what is this CW.
I'm answering the question.
Okay.
Mod x is less than 1.
Mod x is less than 1.
Yeah.
The here, right? Okay. So this is 1 minus mod x, right? When
ये वाला रहने दीजिए नीचे sin omega का
okay, okay. We will think about that thing also. So for Fourier transform, what is the definition? You know, right? Like if fx the Fourier transform is f of alpha, then there is some alpha is some in different domain, variable of different domain, right? So the Fourier transform is defined as integration from minus infinity to infinity function of f like fx and e to the power minus I alpha uh, u not x sorry x dx. Okay, so if we want to calculate the Fourier transform, so this mod x, how you open this mod x is less than 1, then x is less than 1 and greater than minus 1, right? Is it okay? So for in this region, this function fx is 1 minus mod x, right? And after that this is 0. So this limit will convert into minus 1 to 1. And then from in place of fx we put 1 minus mod x and mod x e to the power minus I alpha x dx. Okay, so now we will what we will do, uh, the definition of this one, like 1 minus mod x, what will be the definition? This will be 1 minus x when x less than 0 and 1 minus plus x when x greater than 0. Okay, do you understand this thing? Okay, so thi- this will be minus 1 to 0 and like this limit is break on 0. Okay, function will change. So for that minus 1 to 0, then it will be 1 plus x e to the power minus I alpha x dx. Okay, then plus 0 to 1, then it will be 1 minus x e to the power minus I alpha x. Okay, dx. uh, Now this equation, can you solve? So for that, if you see minus 1 to 0, here will be e to the power minus I alpha x dx, then plus minus 1 to 0 x e to the power minus I alpha x dx, plus 0 to 1 e to the power minus I alpha x plus 0 to 1, sorry, not plus, this will be minus x e to the power minus I alpha x dx. Okay, so we have to integrate all these terms. So from first term we will get e to the power minus I alpha x upon minus I alpha, right? And limit will be minus 1 to 0 plus uh, from here how we will integrate this. First will be same, that will be x. Second, the integration will be e to the power minus I alpha x upon I alpha minus I alpha 0 to sorry minus 1 to x. Okay, then we will put minus sign, then differentiation of this one and integration of this. Okay, sorry, okay, this is 0, sorry, this was misspelled. So from 0 to then minus differentiation of this, integration of this will come to this. Okay, then again we will do integration, so इसका differentiation हो जाएगा 1. Can you understand what I'm saying? uh, I am I am integrating this by part, right? So first same integration of this one, then इसका differentiation 1 हो जाएगा, and after that integration of this will become this part. Okay, then is part again integration. So it will come e to the power minus I alpha x upon minus I alpha and minus I alpha two times हो जाएगा, right? So limit minus 1 to 0. Then from here, because this is same, right? So we can write e to the power alpha x upon minus I alpha. Okay, 0 to 1 plus this will be x e to the power minus I alpha x upon minus I alpha minus 1 to 0. Sorry, oh sorry, 0 to 1. 0 to 1, then minus, or actually it has also minus. Okay, so I think this will also come into minus and this will be plus e to the power minus I alpha x upon minus I alpha whole square to the power 0 to 1. Now you can solve. Okay, okay. So I think they will convert it in sign only, and after that that sign partner, sine c omega is equal to sine omega upon omega, right? So I think c omega will be something from this side, coming to this side. Maybe this to the power minus alpha x and I alpha x, this will convert into the sign in this side, in my guess, if you solve it. But what is this? Why it is coming sign? That is, I am not sure. Because if you are giving some Fourier transform, then this f f alpha will be some function. But they write sine c omega. From where you are getting this question? Assignment number 8. Oh, why you are asking this assignment question? Okay, okay, okay. So, got it. Mm, next, what to do? I will give some question and solve. Can I go for the next question or any next question from your side?
Can you tell me something about frame? What is frame?
Frame. Uh, in what means you are asking frame?
The big we use them in some
That I will cover in next session. Actually, I prepared for this Fourier transform from this session. Is it okay if I tell you next uh, session? Okay. So, like if one question is to evaluate integration minus infinity to infinity sine alpha A and cos alpha A upon alpha and d alpha. Okay, and this is one question. This is next. Integrate 0 to infinity sine u over du. Sorry, sine over sine u over u du, and C is, sorry, only these two questions. So how do you think, how can we solve this? Okay, then yeah, you use limit minus infinity to infinity is given. See, this first one uh, we use with the help of the Fourier transform. Okay, so we know the Fourier transform is given by minus infinity to infinity f of u e to the power minus I uh, alpha u and du. Okay, so if this is the Fourier transform, then the reverse Fourier transform, how can we write that fx is equal to 1 upon 2 pi in integration of minus infinity to infinity this f of alpha and e to the power I alpha a I alpha x into, now we will integrate with respect to d alpha. Okay, so like now if we consider one function fx fx is equal to like 1 when mod x is less than a, and when mod x is greater than a, it will be 0. Okay, so what will be the Fourier transform of this one? From this one we will get the Fourier transform f alpha is equal to 2 sine alpha a upon alpha when a alpha is not equal to, sorry, not equal to 0. Okay, can you find the Fourier transform from this function to this one? Okay, like that the Fourier transform f alpha is equal to 0 to minus infinity to infinity, and this will be f of x e to the power minus uh, alpha u into d alpha du. This is u not x. So this will be minus 1 to 1, and here will be 1 e to the power minus I alpha u du equal to e to the power minus I alpha u over I alpha into minus 1 to 1. Then it will be e to the power I, e to the power I alpha a, sorry, not a, this is minus a to a. So I alpha a minus e to the power minus I alpha a upon I alpha. So it will, if we multiply by 2, then it will be 2 sine alpha a upon alpha. Okay. So if we put for alpha equal to 0, so f of alpha will be 2a. Okay. So from this we can write that we have to find this function, right? So we can write 1 upon pi integration of minus infinity to infinity to sine alpha a upon alpha e to the power I alpha a d alpha. Okay, because we know that from the inverse transform, so this will be our f alpha. So we can write this and plus I upon pi integration minus infinity to infinity sine alpha a sine alpha f upon alpha d alpha. No, this is, oh, sorry, I mixed. Uh, 1 upon 2 pi 2 sine alpha a upon alpha a d alpha. This we can write the inverse transform will go again to that thing. Na? So 1 when mod x is less than a and 1 by 2 when mod x is equal to a and 0 when mod x is greater than a. Okay, so now we open this thing. So how we can write this? 1 upon pi integration of minus infinity to infinity sine alpha a cos alpha x upon alpha d alpha plus I upon pi sine alpha a sine alpha x upon alpha d alpha minus infinity to infinity. So now the integration in the second integral of this equation is odd and so the integral is 0. Then from this 1 and this 2 we can write minus infinity to infinity sine alpha a cos alpha x upon alpha d alpha will be pi pi by 2 and 0 when mod x is less than a mod x is equal to 0 and mod x is greater than a. Okay, and next part we can solve from here, like if x will be 0 and a equal to 1, then this when x is equal to 0 this cos alpha 1 equal to 1 and this will be integration of minus infinity to infinity and this will be sine a alpha upon alpha into d alpha equal to, it will be c x is equal to 0. So x is equal to 0 will be this part. So this will be pi by 2. And since this integration is given, so it will convert into pi by 2. So this will cancel out and will be pi. Okay. So next question is, uh, find the Fourier cosine transform of fx is equal to e to the power minus mx when m is greater than 0. So, and by using this result, uh, we have to find 0 to infinity cos p v upon v square plus beta square dv equal to pi upon 2 beta e to the power minus p beta. Okay, so this is our question. So the Fourier transform, sorry, cosine Fourier transform of fx is equal to e to the power minus mx is defined by this fc alpha equal to 0 to infinity e to the power minus mu cos alpha u and du. Okay, so e to the power minus mu, it will come, this will be same, and integration of this one will be sine alpha u into alpha minus m cos alpha u upon m square plus alpha square. This will be from 0 to infinity. So if you put this limit in this one, this m upon m square plus alpha square. So I think your this condition sin c omega is equal to sin omega by omega. I think this will be cos uh, cosine Fourier transform. So you should find the cosine Fourier transform for that one. Uh, for the example like that. So this Fourier transform will be this one. So the inverse Fourier transform fx, we will have 2 upon pi from 0 to infinity. Fourier cosine transform of alpha into cos alpha x and d alpha. Okay, so this will be e to the power minus n x equal to 2 upon pi 0 to infinity m cos alpha x upon m square plus alpha square d alpha. So the integration of 0 to infinity m cos alpha x upon m square plus alpha square d alpha will be pi e to the power minus mx upon 2, and this m is constant, so it will go here to m. Okay, so now if we replace alpha to v and x to p and this m with beta, then we can easily find 0 to infinity. This m will convert to beta cos v to p upon beta square plus v square dv. Okay, this will come to pi by 2 beta e to the power minus beta p. Okay, so next question we can, this is question solve the integral equation. The integral equation is given 0 to infinity f of x sine alpha x dx equal to integration 1 minus alpha when alpha is 0 to 1 and this is 0 when alpha is greater than 1. Okay, now if we write Fourier sine transform of any function fx, then it will be written sine alpha x dx. Okay, so this will be 1 minus alpha to 0 when alpha 1 0 and alpha is greater than 1, it is 0. So from this we can write from inverse Fourier sine cosine for transform Fourier transform, we can write 2 upon pi integration 0 to infinity f of s alpha sine alpha x t alpha. Okay, so from here you can write 2 upon pi 0 to 1 1 minus alpha sine alpha x d alpha. So it will be 2 x minus sine x upon pi x square. Okay, so this fx will be this. Okay, now one question we will solve on the convolution theorem. So first we will prove how you will prove the convolution theorem. You know the convolution theorem. The convolution theorem is where one function f and one function g, then f dot g will be Fourier inverse transform of f of alpha and g of alpha. Okay, so this will be defined as 1 upon 2 pi integration minus infinity to infinity e to the power I alpha x f alpha and g alpha and d alpha. Okay, so uh, from the help of this, we will show that f of g is equal to g of f. Okay, so how we will prove this one? So to prove this, let's assume x minus u is equal to v. Then what will be the f dot g? It will be minus infinity to infinity f of u g x minus u du. Okay, and this will equal to minus infinity to infinity f of x minus b gv dv. Okay, so we can interchange the function, right? So from this one we can write infinity gv f of x minus b dv. So this we can write to first g and f. So now next question, solve the integral equation. Integral equation is given by yx is equal to gx plus minus infinity to infinity y of u and r x minus u du. Okay, where we have given gx and rx is some function. Okay, so to solve this, suppose this Fourier transform of by x and gx and rx exist. Fourier transform of this by x, gx and rx is exist, and this will be denoted by y alpha, comma capital G alpha, comma capital R alpha. Okay, so if it is these are the Fourier transform, then if we put the Fourier transform of this one, then Fourier transform of by x will be by of alpha, and Fourier transform of this gx will be capital G alpha, and plus this is the convolution. From the convolution theorem you can write this by of alpha and r of alpha. Okay, so from here you can write y alpha is, it will go to this side, is equal to g alpha upon 1 minus r of alpha. So now if we do the inverse Fourier transform this yx, then it will be inverse Fourier transform of g alpha upon 1 minus r alpha. Okay, so you can find this yx will be 1 upon 2 pi minus infinity to infinity and G alpha upon 1 minus R alpha. Okay, into e to the power I alpha x into D alpha. Okay, so let's assume the integration is exists, so you can just find yx by integrating this function. Okay, next question: solve by x the integration equation is minus infinity to infinity y of u du upon x minus u whole square plus alpha square. This will be 1 upon x square plus b square. Okay, so it will be 0 a to b. So how we can proceed this? We have this Fourier transform of 1 upon x square plus b square. It will be minus infinity to infinity e to the power minus alpha I alpha x upon x square plus b square dx. Then it will be equal to 2 0 to infinity cos alpha x upon x square plus b square dx. Okay, so if you solve this integral, it will give 2 1 by 2, sorry, pi by 2 into 1 upon b, and this will be e to the power minus b a, so b alpha. So 2 by 2, so pi by b e to the power minus b alpha. Okay, so we solve this problem before uh, this one. If we take inverse Fourier transform of this one, then what we will get f of y and Fourier transform of 1 upon b square a square plus x square. So it will give the Fourier transform of 1 upon x square plus b square. Okay, so y of alpha multiplied by pi by a e to the power minus a alpha from this relation. It will be pi upon v e to the power minus v alpha. Okay, so this y alpha you can find a upon v e to the power minus v minus a into alpha. So thus we can write yx is equal to 1 upon 2 pi integration of minus infinity to infinity e to the power I alpha x and y of alpha d alpha. Okay, so this will be a upon b pi integration 0 to infinity e to the power minus v minus a alpha cos alpha x d alpha. So here you will get 1 minus a alpha divided by b pi x square plus b minus a whole square. Okay, so for we can find like that. Uh, Next, some question on Fourier integral theorem. So Fourier integral theorem, like one question, just proof limit alpha tends to infinity 0 to L sine alpha v upon b dv will be pi by 2. Okay. Next we have to prove, or you can say like just uh, solve the integration limit alpha tends to b cos alpha sin alpha b upon b, and this limit will be minus L to 0 dv is equal to pi by 2. Okay, so how you prove that? Like one, first we will add alpha v is equal to pi. Okay, then the first is integral limit alpha tends to infinity integration 0 to L sin alpha b upon b dv equal to will be alpha, alpha tends to infinity from limit 0 to alpha L sin alpha y, sorry, sin y upon y dy. Okay, so what will be the integral? Like, if we put the limit alpha tends to infinity, so this will be integration 0 to infinity sin y over y and dy. Okay, so what is the integration of this one? We just recently find that the integration of this thing is equal to pi by 2. Okay, so it's good. Similarly, similarly you can solve this minus L to L problem. That is also we have solved. Next question we will solve like we have one function fx which satisfy one condition that minus infinity to infinity mod fx dx. The integration of this is converse. Here, this converse. Then we have to prove that limit alpha tends to infinity integration 0 to infinity f of x plus b sin alpha b over v dv. So it will be pi by 2 f of x plus 0. Okay, first we will solve that. So to prove this one, first like we have 0 to infinity f of x plus v sin alpha v over v dv. It will be from 0 to L if we convert because this is periodic function. So from 0 to L, this will be f of x plus b sin alpha v over v dv, and again we can write plus integration from L to infinity f of x plus v sin alpha v over v dv. Okay, so this is one equation, and if we put v equal to 0, then we will find 0 to infinity f of x plus 0 sin alpha v over alpha v. Sorry, this is v dv. It will be equal to 0 to L f of x plus 0 sin alpha v over v dv. Okay, plus this limit will go L to infinity f of x plus 0 sin alpha v over v dv. Okay. Now, if we subtract from this, uh, subtract this from this one, what we will get that 0 to infinity f of x plus b minus f of x plus 0 sin alpha v over v dv. Okay, so this will be equal to function 0 to L f of x plus b minus f of x plus 0 sin alpha v over v and dv. Okay, and another term will be from L to infinity f of x plus b sin alpha v over v dv minus another integration 0 will be L to infinity f of x plus 0 sin alpha v over v dv. Okay, so now if we denoting integrals, this I1, I2, I3, so we have this integration I will be I1 plus I2 plus I3, where this is I1, this is I2, and this is I3, and this is I. Okay, so we will we have this I. It will be either less than or equal to mod I1 plus mod I2 plus mod I3. Okay, so now this I1, sorry, I2 mod I2 will be less than or equal to integration L to infinity mod fx plus b sin alpha v over b dv. Okay, so this will be less than equal to 1 by L integration L to infinity f of x plus v dv. Okay, and similarly this I3 mod will be less than mod f x plus 0 integration mod of integration L infinity sin alpha v over e dv. Okay, so now since this 0 to infinity mod fx dx and 0 to infinity sin alpha v over v dv both are converges. Okay, then we can choose a length L large such that this I mod is less than equal to E by 3. Okay, epsilon by 3, epsilon is any small positive integer, and this I3 is also less than E by 3, and I1 is also less than E by 3. So this is when like alpha is very small, then we can choose like that. Then from this equation 4, this equation 4 we can write this I will be less than E for alpha and L sufficiently large. If alpha and L is sufficiently large, then we can write this I less than E. Okay, so in that system we will go to the form Dirichlet portion, and we will do some introduction to Dirichlet and some examples on that one. Okay.